So limits are what distinguish calculus from the rest of mathematics. So let's take a look at those first. So first, recall that if we're looking at a function from r to r, like back in good old single variable calculus, calc 1 through 3, then the limit as x tends to c of f of x exists if and only if. Have you seen the if with two f's before? That's if and only if. There's some number L such that we can ensure that f of x is within epsilon of L whenever x is within delta of c. So in other words, if you say, I want f to be within 1/1000th of L, then I need to be able to say, oh, you can have that as long as you take delta to be 0.0001, right? Something like that. So now let's look at what happens in the higher dimensional case. And now for what comes next, x is going to be an element of Rn. So in other words, I'm going to use x to denote a vector that has coordinates x1, x2, x3, etc., instead of the more familiar notation that we've been using previously where the coordinates are x, y, and z. It turns out to be real bulky to try and write this down using that. So now let's look at a function from Rn into Rm. So a general multivariable function. And we'll take x and c to be elements of Rn. So c is going to have a whole bunch of coordinates, just like x does. Then the limit as x tends to c of f of x is going to be, and now remember f has an output in Rm, so it has m component functions. So this is the limit as x tends to c of, and so we have the first component function f1 of x and the second component function f2 of x, and there's m of these, so the last one is fm of x. And we can move the limit inside. So we have the limit of f1 as x tends to c, and the limit of f2 as x tends to c, and so on and so forth. Whoops. Okay. So we see that the limit exists if and only if each of these component functions has a limit. Okay, so that allows us to take care of understanding the generalization for like what happens now that we're considering a multivariable output, right? And it turns out that the same thing is true for continuity. So that definition we just talked about was for limits existing. For continuity, for a function of a single variable, good old single variable calculus, f is continuous at a given point if and only if the limit as x tends to c of f exists and critically equals the value that the function is prescribed to be at that particular point. And so now for a function from Rn to Rm, f is continuous at a point c, which is now a point in Rn, if and only if, and we have the same thing, except now this is for each component function. Okay. So that takes care of the generalization of R changing to RM in the codomain. Now we get to the hard part, which is, what about the fact that now our input variable has multiple coordinates? So this is where things get a little bit crazy. So the limit as x tends to c of f of x, this one exists if and only if the limit exists along all paths approaching C. So if we're in the single variable case, right, and we want to find out if the limit exists for the function at some point C, there's only two possible directions you can come in from. You can say, okay, do we come in, what are things looking like as we come in from the left side? And then as we come in from the right side, does it meet up with it or does it go somewhere else, right? But that's all you have to check. So you need to check the limit as x tends to c from the left side and the limit as x tends to c from the right side, and are those equal? Okay, now that we're in multivariable calculus, suppose we've got a function of two variables and we want to know what's going on at some point C. How do we get to the point C? Well, we could come in moving parallel to the x-axis in either direction, or parallel to the y-axis in either direction, or we could come in along some like diagonal line, or we could come in on some spiral line like this. We could do all kinds of things, right? So when I say all paths, I mean every single possible way. And that makes things more challenging because strange things can happen. Strange things are done in the midnight sun by the men who moil for gold, and the Arctic trails have their secret tales that would make your blood run cold. We'll do some examples in the next clip.